this app helps to understand what multiple linear regression is. We use a simplest case where we have two x variables, two predictors, so x1 and x2. You can think, for example, as a, I don't know, temperature and time of reaction. And then we have also the response, the value that we want to predict, which is, for example, can be a yield of chemical reaction. And then what you see here, it's an equation, it's a multiple linear regression model, which consists of several coefficients, b0, b1, b2, b1, 2, that we will talk about a bit later. And then you can see the visual representation of this regression. You can use mouse or you can use arrows on your keyboard to rotate this. So this plane that you see here, it's actually the visual representation of this model. So let's look at that a little bit closer. You can see that these are three main coefficients. So b0, b1, b2. We will talk about this one a bit later. So what's the meaning of the coefficients? The idea, or actually the overall idea of any regression, is that for any combination of x1 and x2, you have a single value that corresponds to this combination along the y, right? So this is the predicted value. Then you can see I can change the x1 coordinate and x2 coordinate of my point. So you can see I change x1 now. Now I change x2, and then for any combination, I have one single value that lies on this plane, and this is exactly the predicted y value. But how it is predicted? So the predicted y value, it's a linear combination of these three main contributors, right? Let's start with b0. If you look at this top equation, you can see here I have the real coefficients. So you can see that b0 is 10, and this is where I set it to 10, so it's a default smallest value for b0. And then you can see b1 is 0, b2 is 0, and this coefficient is also 0. What does it mean? It means that in this simplest equation, we don't have any contribution from x1, we don't have any contribution from x2. We have only one constant value. So y is always equal to 10, regardless which x1 and x2 I actually choose. So you can see that I change x1, you can see it here, I change x2, but y value remains the same, it's 10, right? And this is the meaning of this 10, the b0. b0 is what y will be equal to if you don't have any contribution from x1 and x2. Okay, and then you can clearly see that actually the plane, the model plane, is parallel to x1 and x2, and this is why we don't have any influence from x1 and x2. Now let's change b1, so it's a contribution from x1 to, for example, 0.2. What happened? Well, first of all, you can see that this value is not 10 anymore, it's 10.44. Why it's bigger? Because now we have this initial value, which was 10, and then we have also a little contribution from x1. You can see x1 is 2.2 times 0.2, it will be 0.44, and that adds on top of this initial value, right? And then if I change it, you can see that when I change the x1, indeed, y value also changes, right? And then you can see we have a kind of positive relationship between x1 and y. I can show you only values for x1. You can see that these are lines that corresponds to changes for x1. Then you can see that we just go along this line. So every this line, it's a simple linear regression model for different x2 values. But because contribution from x2 is 0, it doesn't matter what x2 I choose, because all these lines, they have the same slope. You can see they have the same slope because we don't have a contribution from x2 yet, right? But you can clearly see a slope from x1. So if I start changing x1, b1, the regression coefficients, you can see slope gets larger. Or if I, for example, make it negative, slope will be negative. So you can see this is 0. For example, 6, negative 0.6. It means that we subtract from the initial value the contribution from x1, right? So you can see it's 0.6 times 2, and then we subtract it from 10. Okay, and then this is how the plane looks like. Likewise, I can set contribution from x1 to 0, like this. And then I can change the contribution from x2, for example, to 0.4, right? And now you can see that we have another direction, so I can switch lines like this. So now you can see that we have a slope along x2, not along x1. Along x1, we don't have any slope. You can see that all these lines, they are parallel, but all these lines, they have the same elevation. But you can see that now we have a slope for x2. And then if I change x2, you can see still we have a bit larger or a little bit smaller y. Right? Now, what's the meaning of these exact values? For example, what is exactly 0.4? 0.4, it's how big will be the increase in y if I change x2 by 1. So for example, in this case, you can see it's 0.8, right? 10.8. Why? Well, we started with 10, and then we have x2 equal to 2. And then we have 2 times 0.4, so it means 2 times this regression coefficient. What happened if I change the x2 from 2 to 3? Let me do that. So let's remember that this is 10.8, right? Now I increase x2 by 1, so now it's 3. And then you can see that this is exactly by 0.4 larger, and 0.4, it's a regression coefficient for x2, right? So this is a contribution for x2. So it means that every time you change x2 by 1, your y value will change by this value. Of course, you can have both. So you can, for example, have 0.4 for x1 and 0.4 for, let me use 0.2 for x1. So it means that we have a contribution from x1, which is 0.2. So every time we change x1 by 1, y grows with 0.2. Every time we change x2 by 1, y grows by 0.4. So if we change both, y will be significantly larger, right? So for example, in this case, you can see we have x1 equal to 2, x2 equal to 3. So we have 2 times 0.2 from x1. We have 3 times 0.4 from x2. Altogether, you can see it's 1.6, which is exactly we see here. So 1.6 plus 10, it will be 11.6, right? And then if I change, for example, b0, it simply change the elevation. You can see it doesn't change the slope, but it changed the elevation of this plane, right? Now you can see that this plane has a little bit more complex structure. So now I show both lines. So now you can see that we have slope in this direction. And then we also have a little bit smaller, like twice smaller slope in this direction, because now we have contribution from both, right? So you can see we change contribution from x1, we change contribution from x2, we change slope along x1, and we change slope along x2. So this is kind of simple, right? So y is just a sum of two contributions, and these contributions are independent. So it means that contribution from x1 does not depend on x2, and contribution from x2 does not depend on x1. But it's not always the case. For example, if you think about chemical reaction, like time and temperature as two contributors, and the yield as a response, you know that the higher temperature is, the faster reaction is. And therefore, if you, for example, run reaction for 1 minute and having, for example, ambient temperature, or run reaction for 1 minute and having, for example, temperature which is higher than ambient, for example, 40 degrees, of course, the outcome of this reaction will be different, right? So the effect of time depends also on the temperature. This situation, when effect from one predictor depends on the value of the other predictor, we call it interaction. And this is exactly this term that is responsible for interaction, right? So this term tells us how changes the effect of time, for example, if we change the temperature, or vice versa, how changes the effect from temperature if we change time. So first of all, let me change let me use 0.2 here. It's a contribution, it's a regression coefficient for x2, so it's a contribution from magnitude of contribution from x2, 0.2 here. And now let me change this to, for example, 0.01, yeah? So what's the meaning of this? Now let's say x1 is fixed, and it's 2. What happens if I change x2 from 3 to 4? Well, on one hand, we know that this is the contribution from x2, right? So if I change it from 3 to 4, it's by 1, so it means that y should be larger by 0.2. But this is not fully correct, because now we also have the interaction, and interaction depends on x1, right? So you can see that x1 is equal to 2. I don't change it. And therefore, it's kind of additional slope. It gives you additional slope for contribution from x2. You can see, and this slope will be approximately 0.2. So you have 0.2 from original contribution, and then you will have 0.2 on top of that. So the increase will be 0.4. Let's check it. So I increase from 3 to 4, and then you can see indeed we have 12.7. So increase of 0.4, right? So let me go back. And then you can see this is 12.3. So the difference is 0.4. Okay. So this is exactly what interaction is. How you can see the interaction? You can see that our plane is not a plane anymore, right? It's a kind of a surface. And then you can see, for example, the slope of this lines that we have, this, you remember these lines, it's a contribution from x2, it's a slope for x2 for different x1 values. And now they are not parallel anymore. You can see that they change the slope. So the slope for x2 depends on also on x1. So the smaller x1, the smaller slope is. You can see it clearly here, right? And then if I change the interaction, if I make it even larger, you can see that this difference in slope of these lines is even larger. And vice versa, it's the same for this one, right? So you can see that the slope for x1 also depends on the value of x2. You can see here we have the largest slope. Let me just use it like this. Here we have the largest slope when x2 is large, and then here we have the smallest slope when x2 is small. If interaction is negative, then it will be just the inverse. So when you can see that in this case I have negative interaction, so slope from x1 will be negative if x2 is large, and it will be positive or slightly positive when x2 is small. In this case, when x2 is negative, right? So this is what interaction is. So interaction is when effect from one factor depends on which value you have for the second factor and vice versa. So I recommend you to play a little bit with the coefficients, with values for x1 and x2, and then rotate it for a better visibility. You can also zoom in and zoom out using either mouse scroll, or you can use also plus minus on the keyboard. And then just play with that and hopefully get a better understanding how multiple linear regression works.